Hello, hello, hello everyone. Welcome back to the channel. So I hope I'm audible. And yes, so today there was this CodeChef starters contest, and I did attend that. And we will take a look at the solutions of some of the problems, like I think fourth and fifth problems. I don't really remember, but let's see this. Binary removals. So given us binary string s of length n and two integers x and k, your task is to empty the string by performing following operation. So in one operation, you may select any subsequence of the string such that the number of inversions in the subsequence lies in the range 0 to x and is divisible by k. So this statement is quite tricky. And remove the selected subsequence from the string. Okay, so your task is to determine the minimum number of operations required to empty the string. Okay, so I can select any of the subsequence, right? So let us take a look at this test case. Okay, right. So in this test case, I can notice that uh, one more thing to notice, that suppose my string is 1111, so consisting of all the ones, so my inversion count is going to be 0, right? And similar is the case for the string which only has zeros. Okay, similar is the case for the string having all the zeros, right? Okay, so that is one key observation. And by this key observation, I can found upper bound on the answer. Can I find that? Okay, let's take a look. So I can always select uh, two substrings. Okay, subsequences, not substrings. So I can always select two subsequences such that first subsequences is all the ones in the string, all the ones, and second subsequence is that all the zeros from the string. Okay, right? So from this string I can always select 1 1 1 1 and then 0 and 0. So number of inversions for both of these subsequences is going to be 0, which is perfectly divisible by the given integer x, right? And it is also given that x is positive. Okay, non-negative, so x is starting from 0, so we don't need to worry that if this 0 is less than or equal to x or not. Okay, so 0 is definitely divisible by k. So in any case my answer is not exceeding 2. Okay, and I know that my answer is greater than 0, right? So basically, at least I have to do the one operation to vanish the string, right? So I have only two candidates left for my answer, 1 comma 2. Okay, so if the answer is not 1, it is definitely 2. Okay, so how will we find if the answer is not 1? That is simple, right? So for, let us suppose, this given string only will consider. So let's take it here, increase its size, and yeah, so we will maintain one suffix array maintain a suffix array which will store how many zeros are there in the suffix. Zeros are there in the corresponding suffix. Yeah, so formally suffix of I will represent the number of zeros from I plus 1 to nth index. Okay, so we are considering one based indexing here. And yes, we will build this suffix array, and we will start looping from 1 to n. So basically when we'll come here, here suffix of 1 is going to be 2, right? So suffix of 1 is going to be 2, suffix of 2 is going to be 2, suffix of 3 is going to be 2, suffix of 4 is going to be 1, suffix of 5 is going to be 1, suffix of 6 is going to be 0. So okay, 0 is somewhat like this, not perfect circle. Okay, so yes, we start looping from I is equal to 1 to n, and if the character is 1, okay, basically if the character is 1, then the number of inversions for that index uh, is basically equal to the number of zeros after that index, right? So basically count of inversions will be plus is equal to str of I. String is str is just given string of I is equal to 1. If it is 1, then multiply it with the suffix of I. Okay, so this way we'll calculate total number of inversions. So after calculating total number of inversions, we'll check if it is less than or equal to x and greater than or equal to 0. So basically this inequality is trivially true. We need to check for this inequality, and if it holds, we also need to check that if number of inversions is uh, completely divisible by k, and if these both the conditions are satisfied, then my answer will be 1. Otherwise my answer will be 2. Okay, so I think that's the crystal clear explanation for the problem. Code is pretty straightforward, but let us take a look at the code as well. So inputting t number of test cases, then n, x and k, which are the input parameters, and string as well. So this is one clever way to ensure the line number 15. So this is basically the clever way to ensure one based indexing. And this part from here to here calculates the suffix array. This part okay, this part from here to here calculates the number of inversions, and if inversions are less than or equal to x and inversions are perfectly divisible by k, then our answer is going to be 1, otherwise it will be 2. And yes, pretty straightforward and easy to follow code. Let us head to the second question. Okay, so questions title is no two alike, and this was also slightly tricky question. So let's see. You are given an array of length. You are given an array of length n. Your goal is to make all elements of a distinct. To achieve this, you can perform the following operation any number of times. So you can select L and R and erase uh, the duplicate entries of the elements in the range L to R in the array A. Okay, so the cost of performing this operation is number of distinct elements in the initial subarray A L to R before doing this operation. Okay, so your task is to calculate the minimum total cost required to make all elements of the final array A distinct. Okay, so What what do they mean by this before doing the operation? Okay, so after doing the operations, uh, suppose before doing the operation means uh, if you are overthinker, you may get stuck at this statement. So why are they saying something like before doing this operation? So after doing this operation, a number of uh, elements in that range L to R will change, right? So basically, after vanishing, some elements from the right of the R will come in that range, right? So basically, your number of distinct elements in the range will change, right? So that is not what we want. So we will calculate them before doing this operation and add it to our cost. So yes, that's what that means, and your task is to calculate the minimum total cost required to make all elements of the final array A distinct. Okay, so let us take a look at some test cases. So what I can notice is that suppose my test case is something like, okay, okay, so suppose if my test case is like 1 2, suppose here it is 8 10 1 2 4. Okay, let me write down the test case. Okay, so I'm done. And n for our test case is 15. Okay, so what I can notice is that, so definitely if I want to make uh, array elements distinct, I need to select this range, right? So I need to select what you can say, this range. Okay, I can select this explicitly. Okay, or otherwise it can be subset of some range, right? Right. So what I can notice is that if I select this and then select this range, I am double counting this 4, right? I am counting this 4 two times. So which is not what I want, right? So I want to minimize the cost. So instead of selecting this 3 to 3, I will select 2 to 2 in its place, right? And instead of selecting 2 to 2, this thing, so this thing, I will select here, right? I will select this portion, isn't it? So if I select this, then this 2 will say, hey, what you are doing? This 2 is still remaining, right? So you need to consider that 2 as well. So you will consider of this thing. Okay. Then this 5 will say, hey, my multiple is also there. Oh, not my multiple, my duplicate is also there. You also need to consider me. So this 5 will say that you need to consider me as well. Okay, my duplicate as well. You have to remove it. So basically what I can notice is that it is inevitable to choose this segment, right? 1 to 1, then this 2 to 2, and this 5 to 5, and this 3 to 3. So what I will do is that I will select union of those segments, right? So if I select this segment, so if I basically go with this segment, okay, that's the straight line, nice. Okay, and yes, if I select this segment, then my issues are gone, right? So anyways, this 8, 10, and 6 and 7 are appearing only one times. so they are not causing any problem. So what I need to do is that I need to perform that operation on the union of the segments. So that is basically only the only key observation you need to solve this question. Only key observation you need to solve this question. And there is a method or a standard code from which you can get the union of the segments. So basically I'll directly head you towards the code. Yes, so basically this is type of standard code. This line number 6 to line number 36, so 6 square, that's nice. And this function basically returns you the vector of this segments. So segment is basically pair of long long comma long long. This basically returns you the vector of this segment, which has the segments joined, or you can say performed union upon. So if that function is given, okay, that function is given argument of a vector of the segments. Okay, so basically if it is given 1 to 5, 4 to 10, so the vector containing these elements, so wait, there are more, 11 to 20, 12 to 22, 22 to 30, and 31 to 33, suppose. So this is my argument vector, or what you can say, the function parameter. So my function will return a vector containing 1 to 10, because these two overlap, then 11 to 20, these two overlap, these two also overlap, so basically 11 to 30, and 31 to 33. And finally, after receiving this union of the segments, I can iterate over 1 to 10, count the number of distinct elements, add it to my answer or my cost. Similarly, I can iterate from 11 to 30 and 31 to 33. Okay, wait. 30, okay, so this both will also converge, right? So converge or merge, you can say. So 1 comma 10 to 11 comma, okay, wait. So this will also merge, right? So basically it will give 1 comma 33 as a whole. So I should have chosen some other example, but yes, you've got an idea, right? So how to proceed. And basically we will count the number of distinct elements from for every segment that our function has provided us, and add it to the answer or cost, you can say, and finally outputting that cost. So yes, this is the function which gives me the union of the segments provided, and basically that's the input. And how do you construct this vector which is given as input to the our function? So that is basically very simple. So I will uh, initialize one dummy vector position. So basically I am following one based indexing, and initialize all of its values as -1 comma -1. And suppose that element hasn't occurred in array, so its first argument, so basically it will be -1, right? So first position. And if it is it has already occurred in the array, then simply its second appearance, or the last most appearance, not second, the last most appearance, whenever it has occurred, and first argument of this pair, the segment pair, is fixed, then you need to uh, what you can say, you need to assign the maximum index of where the last most maximum index where the appearance of this v of I has taken place. Okay, so yes, and so if elements are only present once, then no need to push them into our segment, and that is this if condition checking. And finally, we are providing this segments vector to our function, and to check the number of distinct characters in the elements which are present in this union of segments, we initialize a map, empty map, and count the number of distinct elements, add it to the cost or the answer, and for every segment in this union of segments, we clear the map for the further segment for the calculations related to the further segment, and finally outputting the answer. So yes, pretty straightforward code and easy to follow code, and hope you enjoyed solving the problems in the contest or practice, whatever it is. And I'm happy that you listened till the end. Yes, so thank you for watching. Consider liking the video and staying subscribed and staying tuned to the channel. So yes, thank you again.